Section 11.2 Contingency Table. A contingency table, or two-way frequency table, is a table consisting of frequency counts of categorical data corresponding to two different variables. In a test of independence, we test the null hypothesis that in the contingency table, the row and the column variables are independent. In this section, we are going to learn how to conduct a hypothesis test of independence between the row variable and column variable in a contingency table. O represents the observed frequency. E represents the expected frequency. R represents the number of rows in a contingency table. C represents the number of columns in a contingency table. The requirement for test of independence: 1. The sample data are randomly selected. 2. The sample data are represented as a frequency counts in a two-way table. 3. For every cell in a contingency table, the expected frequency E is at least 5. This is how you are going to set up the hypothesis for test of independence. For HO, this is going to be a statement stating that the row and the column variables are independent. HA is a statement the row and column variables are dependent. The formula for chi-square is the same. Chi-square equals to the sum of O minus E squared over E. However, we will use StatCrunch to find chi-square and p-value. Example 1. The table on the next slide is a contingency table with 4 rows and 2 columns. The cells of the table contain frequency counts. The frequency counts are the observed values. The row variable identifies the treatment used for a stress fracture in a foot bone, and the column variable identifies the outcome as success or failure. We have 2 variables. The first one is the treatment that we use, and the second one is the outcome, either success or failure. This is the contingency table, or can also be called a two-way table. The rows are the treatments that we used, and the column are the outcomes that we have. For the treatments, we have 4 different treatments, and for the outcome, we have 2 different outcomes, either success or failure. The numbers in this table are the frequency. For example, I have 54 people got the surgery and the outcome is success. Or 51 people got the weight-bearing cast and the outcome is failure. Use a 0.05 significance level to test the claim that success of the treatment is independent of the type of the treatment. What they want me to do is to test the claim that if the outcome is independent with the treatments. My HO is going to be statements stating that my outcome and the type of treatment are independent. My HA is going to be a statement that my outcome of the treatment is dependent to the type of the treatment. The difference between HO and HA is that HO is a statement that stating the 2 variables are independent, and HA is a statement stating that the 2 variables are dependent. You can also use not independent to represent dependent as well. Significance level is 5%. I will use StatCrunch for my test statistic and my p-value. When you're importing the data into StatCrunch, Always make sure to import the row label into one of the columns. And click on Stat, Table, Contingency with Summary. When I'm selecting the columns, I do not select the column that saved my row label. I only select the success and the failure column. For the row labels, I choose a column where I save my row labels and compute. This is my test statistic and this is my p-value. Please always read the instruction to see how many decimal places you should round to. For this number, I am going to round it to 3 decimal places. For p-value, they didn't give me the actual p-value. All they told me is that p-value is less than 0.0001. Since p-value is less than 0.0001, it will be less than 0.05. I will reject HO because p-value is less than alpha. HO says success of treatment is independent of the type of treatment. And I reject this. That means I don't think this is true. That means I think success of treatment is dependent of the type of treatment. Example 2. A study of seatbelt users and non-users viewed the randomly selected data summarized in the table. Use a 0.05 significance level to test the claim that the amount of smoking is independent of the seatbelt use. I'm given a contingency table. The rows are the variable whether or not people wear seatbelt. The columns are the variables of the number of cigarettes smoked per day. For example, there are 30 people who wear seatbelts and smoke from 1 to 14 cigarettes per day. 11 people who don't wear seatbelts and smoke 35 or more cigarettes per day. And I want to test the claim that whether or not if they wear seatbelt and the number of cigarettes they smoke are independent. My HO will be the amount of smoking is independent of the seatbelt use. And my HA will be the amount of smoking is dependent of the seatbelt use. I have my HO is the amount of smoking is independent of the seatbelt use. And HA is the amount of smoking is not independent of the seatbelt use. You can use either not independent or dependent, they are similar. Significance level is 0.05. I will use StatCrunch for my test statistic and my p-value. For this table, the first column is a column where I save my row labels. The other 4 columns are my frequencies. Click on Stat, Tables, Contingency with Summary. When I select the column, I do not select the first column because this is where my row labels are. Just select the other columns. And for the row labels, I'll select the first column. Compute. This is my chi-square, and this is my p-value. Chi-square is 7.376065. I will round this to 3 decimal places. 7.376. P-value is 0.0608. P-value is greater than alpha, so I will not reject HO. HO is not rejected. That means I think the amount of smoking is independent of seatbelt use.